Bismillahirrahmanirrahim. We need to discuss the existence of limit x multiply y over x square plus y square as x and y approaches to the origin point 0 and 0. We need to discuss the existence of this limit. If it exists, we need to find the value. Otherwise, we may say that the limit does not exist. To discuss, as we can see that this limit is a limit in two variables, يعني the function in f of x y in two variable x multiply y over x square plus y square. So we need to use the techniques of evaluating limits in two variables. It is clear that this function f x and y, يعني if we define the function f x and y equals x multiply y over x square plus y square, we know that this function is a function in two variables. This function is continuous everywhere except when x equals 0 and y equals 0. يعني it is clear that this function f and xy is continuous everywhere except the origin point, 0 and 0. But the challenge here in this problem, our challenge is to evaluate the limit at the origin point itself, 0 and 0. So this is the challenge. So direct substitution is not valid here. يعني we cannot put x equals 0 and y equals 0 directly, because at this point the function is not continuous or discontinuous. All what we do now, we can do now, we will try to solve this limit using the parametric method. For example, we know that the x-axis, for the x-axis, the parametric solution of the x-axis is, if we consider the xy plane, this is the xy plane. For example, if we take the x-axis, the parametric solution of the x-axis is x equal t and y equal 0. يعني for this system of coordinates, we have a parametric solution x equal t and y equal 0. T means what? T means any real number. T is any real number. It's called a parameter and belongs to the set of real numbers. So if we put y equal 0, this means you are moving on this line. To change the position of every point on this line, x-axis, just change the variable of the parameter t according to the line number or the real numbers. So from the analytic geometry, we know this fact. The parametric solution of x-axis is x equal t and y equal 0, where t is a real number. Also, in the same way, similarly, the parametric solution of the y-axis is y equal t and x equal 0. This is also the parametric solution of the y-axis. This is from this background from the analytic geometry. Now we will use this fact to discuss the existence of this limit. The existence of the limit, if we read or try to evaluate this limit on the x-axis, for example, so we will use the parametric equation of the x-axis. يعني now we discuss the limit on x-axis. The parametric solution, as we have said, of the x-axis, x equal t and y equal 0. This is the parametric solution of x-axis where t is any real number. يعني on the line number. So if we substitute in this limit, we put x equal t and y equal 0. This limit becomes, this limit in this case, equal if we substitute x equal t and y equal 0. So this limit is reduced to the following. T, we replace x by t and y by 0 over t square plus 0 square equals 0. As when x equals 0, so t equals 0. When x equals 0, so t equals 0. So this limit is reduced to 0 multiply 0 equal 0 over t square as t approaches to 0. So 0 over any real number equals 0, and then this limit equal 0 on the x-axis. يعني on the x-axis this limit equals 0. Then we will discuss this limit on another axis اللي هو on the another line اللي هو the line y equal x. We will take the line equal x. This is the line equal x. Another line يعني. Another line. We will discuss the existence of the same limit on the another line y equal x. We know that this line y equal x, yeah, the image of the element x equal itself. يعني the image of 0 is 0, the image of 1 1, image of 2 2, and so on. So this is the image, this is the line y equal x. The parametric equation of this line y equal x, if we put x equal t for this line, the parametric equation, if we put x equal t, then also y equal t. Why? Because y equal x. So the parametric equation of the red line, y equal x, if we put x equal t, a real number, then y also equal the same real number t, where t is any real number. So x equal t and y equal t is a parametric equation of the line y equals x, which passes the origin like this. So now we will study the existence of this limit on the line y equal x. To discuss the existence of this limit on the line y equal x, we will use the parametric equation here. يعني second, we discuss the limit on the line y equal x, where the parametric equation of this line y equal x equal t, as we said before. So if we take the limit equal this limit. If we take this limit again, it equals, we put x equal t and also y equal t. So t multiply t equal t square over x equal t يبقى هنا t square, and y equal t also يبقى هنا t square. طبعا as x approaches to 0 يبقى t approaches to 0, also as y approaches to 0 يبقى t approaches to 0. So the variable of the limit t approaches to 0. To evaluate this limit, we multiply t equal t square. So the numerator of the limit equal t square, and the denominator t square plus t square equal to t square as t approaches to 0. To simplify this limit, it is easy to see that, it is easy to check that t square can be cancelled with t square. So the limit, this quotient is reduced to half. So this is equal limit half as t approaches to 0 and the limit equal half. Now we have two different values of the limit. The first value is 0 on the x-axis. The second value of the limit is half on the line y equal x. So this limit has two different values. This limit has two different values. One is 0 on the x-axis and one is half on the line y equal x. So the limit does not exist. This limit, now we proved that it does not exist. Why? Because the limit itself has two different values in two different paths. For example, the line y equal x and the line and the x-axis. This is a method to solve this lesson. We have also another method to solve this limit. We have another method to solve this limit. We will discuss the existence of the limit on the line y equal mx. This is another method to obtain the same result. For example, we will use the substitution y equal mx. We will use this substitution in this limit, in our limit. This substitution will make the two variable limit a single variable limit. But we need to know that in this substitution y equal mx means align. This means align in the plane xy and intersects the origin like this with slope m. The y equal mx, this substitution means a straight line with slope m. M here, the slope of the line, the red line. M, for example, if m equal 1, we will obtain the line y equal x, which has been used in the last solution. If we put m equal 0, we will have the equation of the x-axis, y equal 0, the x-axis, if we put m equal 0. If we put m equal 2, we will obtain a line intersects the origin with slope 2 and so on. So this equation y equal mx represents a family of lines crosses the origin. This is the geometric meaning of this substitution y equal mx. Now if we put this substitution in our limit is reduced to limit x multiply y over x squared plus y squared as x and y goes to the origin. This is equal. Now use the substitution. So x as it is, we will replace y by what? Y by mx. So y multiply mx over x squared as it is. And we also replace y squared by y by mx. So y squared will be m squared x squared. طبعا as x and y approach to 0, so if we put x equal 0 here, y also equal 0, so the variable of the limit here is a single variable, only x, so x approaches to 0. Now we know that, it is clear that this limit is a single variable limit using or by virtue of this substitution. To simplify this limit, this is equal, if we multiply x multiply mx, this will be m multiply x square. And if we take here from in the denominator, if we take x square as a common factor, so we'll obtain x square, open bracket, 1 plus m square like this. طبعا as x approaches to 0. The variable here of the limit is not m, it is x. So we will keep x square on the right of the limit, and we will take the constant m and the constant 1 plus m square outside the limit, because these are constants. These quantities are constants. The limit does not depend on these quantities. These are constants because the variable of the limit is x. Okay, so we will take m over 1 plus m square as a common factor outside the limit. So the limit is reduced to m over 1 plus m square multiply limit x square over x squared. We take this parts as a common factor, that remains from the numerator x square and from the denominator 1 plus x square as x approaches to 0. It is clear that x square can be cancelled with x square, the same quantities. So this part equal 1. So the limit of 1 equal 1. So the total answer of the limit equals m over 1 plus m square. Now this limit is reduced to this quantity, m over 1 plus m square. What is m? m is the slope of this line. يعني whenever you change the line, you obtain a different slope, then a different value of the limit. يعني for example, if we put m equal 1, if we put m equal 1, this case is reduced to the example y equal x. When m equal 1, so the line we obtain the line y equal x, the line we have used before in our last solution. So the line y equal x, m equal 1, substitute in the limit with m, replace m with 1, so the limit equals 1 over 1 plus 1 square equal 1 also, so the limit equal half as we have obtained before. For the case of the limit, for the case of the line y equal x, we obtained before the limit equal half. This is the same confirmation to the limit using the another method. Also, for the case of the x-axis, this is the x-axis. The equation of the x-axis is y equals 0. So m here, for the case of x-axis y equals 0, m equals 0. Okay? So if we put in this formula, if we replace m equals 0, if m equal 0, which means the case of the x-axis, this means that y equals 0. Y equals 0 is the equation of x-axis as we know. So replace in this limit, put m equals 0. So then the limit equals 0 over 1 plus 0 square 0. So equal 0 over 1, يعني equal 0. So as we have obtained before, we checked that using the parametric method. The limit on the x-axis equals 0. This is another confirmation to our previous finding. The limit on the x-axis equals 0, and the limit on the line y equal x equal half. So the limit has different values on different paths. this means that our limit does not exist. And this is another method confirms that the limit does not exist. And thank you very much.